Hi, this is Miss Litton, and this is a APBio review for our Unit 6 exam. Let's talk about the big ticket items. I want to remind you the essays we have already discussed. Who was here for the essay review? And we did content as well on those days, some pretty detailed content. It's long, it doesn't have a lot of pictures, it has a lot of voices though. So I encourage you to look at that. So let's just list off the different chapters. We have chapter 31, and what is that mostly focused on?
Homeostasis.
Yeah, homeostasis. Now in our book on homeostasis, on that chapter, there's also all the different tissues, right? And as far as what you need to know when you walk away from that is you want to focus on the organization of life. So let's review the organization. It goes what? Atom. Tell me. Atom. Molecules. Or please be stronger than this. Go again. Atoms.
Molecules, organelles, cells,
Tissues. Organs. Organ systems. Organisms. Look, they still know it. Population. Community. Ecosystem. Biosphere. Thank you. All right. So this chapter focused on those tissues, and then it went into homeostasis. When I think homeostasis, what do you think are some key things I would want you to walk away with? Yeah.
positive and negative feedback.
Exactly. So review your positive and negative feedback and an example of each. Okay, definitely on that feedback. Okay. Okay, then the next chapters are atom, molecule, organelle, cell, tissue. That chapter was on tissues. What goes up from that? Organs and what? Organ systems. For all organs and organ systems, what are the systems you have to know? Nervous. Is that in this unit? No, so we'll take that one off, but I wanted you to tell me. Nervous, what's another one? Yeah, immune and endocrine. Of those three, which one is in this unit? Immune. So do you think you need to know that chapter, cold stone? Yes. Okay? You need to know that one for sure. Chapter 32, though, is about what? What is chapter 32 about?
Circulatory system.
Circulatory systems. Only the circulatory systems? What else was it about? What was the ed puzzle part I had you do ahead of time? It was just basically about transport, right? And how cells meet their nutrient and gas needs. So with all of these, the big idea you need to know is how structure what?
Meets function.
Structure meets function. So you want to think about, when you talk about this chapter, you're going to want to focus on things like diffusion. And you know the cell theory says what? What does the cell theory say? All living things are composed of cells. Cells are the structural and functional unit of an organism, right? So even though we're a multicellular organism, all of our cells will operate on that single cell basis in that sense of diffusion, right? So those cell membranes play a vital role in that process. So you want to look at things like unicellular organisms, like an amoeba. You want to look at a step up at multicellular organisms, things that use their gastrovascular cavity and their external surfaces in order for gas exchange and nutrient exchange. You want to look at examples of organisms that have open versus what? Closed circulatory system, and why that still works for them. You know, in a closed circulatory system, all your fluids stay, or your blood, we call it blood then, in your vessels, whereas an open circulatory system, it can be in a vessel and then it can be oozing through the body. And what do we call that? Hemolymph. But that fluid moving through the body, it's not transporting one thing that our blood transports. It's not transporting one thing. What is that one thing? Your gases, right? How do gases, when you have an open circulatory system, do you remember how that gets to those, to their cells? Tracheal tubes, delivering those tiny little tubes. Remember the openings, the spiracles on the side? and the branching tubes that go in, and it delivers gases directly to it. So look for those differences. I'll pull that up again. All right, what was the other chapter that we had? Chapter 32, and then we had chapter 33. What was that? Immune, so we want to hit that hard. Because that's a for sure, you have to know that one. Okay, then what was the next chapter we did?
34.
Yeah, chapter 34, and what was that one about? Digestion. Okay, now, those of you in period 1, I recorded period 3's overview of the entire digestive system and the importance and the adaptation, so you have that available to you as well. All right, so did we hit them all? 31, 32, 33, 34. So on your circulation and cardiovascular systems, some key things at the beginning you're going to want to review, and that'll be up to you, these types of things. Okay, and you can do that on your ed puzzle. Okay, knowing the difference between the two fluids, blood versus hemolymph, open versus closed circulatory system, and examples. And then let's get into our system. We're going to want to know some things. We're going to, again, how does structure meet function in arteries, veins, and capillaries? What is their anatomy? How does it help them to do? Why does the artery have more muscle on it? Because it has to withstand the pressure on it with the blood and the force due to the heart. Why are the veins wider? Why is their lumen wider? Because they have to accommodate more blood, because the blood is moving more slowly through the veins than it is in the arteries in the systemic circuit. Yes? Why do they have valves? Why that structure? Yeah, to keep the blood flowing in one direction. Valves are about moving the blood in one direction. Okay? So capillaries are 1 cell thick. Why? To facilitate exchange, diffusion. Good. So we went through that part. We also did some comparisons of different types of hearts and systems. You might want to just, review that. We looked at blood flow through the heart, and we thought of it like a box, right? So you could review that. Remember the things we needed to remember on that. We had to remember that arteries go away and veins go towards. Then you need to remember your lefts and your rights as if it's on you. And then you need to remember anything to do with the lungs was, what was the word we were looking for there? Pulmonary. Okay? So you have, you already have things recorded on reviewing that. And I know you're all at different places on that. But you might review that process and how it goes through in the different circuits. The sounds of the heart. What are we hearing when we're thinking about heart sounds? We're actually hearing the love dub, but what is that? Valves opening and closing. Good. When you feel your pulse, you're feeling the expansion on a arterial wall. What controls our heart rate?
Medulla
oblongata, which tells who? Who does he talk to? Yeah, SA node, right? And the SA node is actually known as the what of the heart? Pacemaker of the heart. You get a wave of depolarization across the atria, and that would be the what in our electrocardiogram? P. Right? Then it hits what node next? SA node and then the?
QRS.
Right, it will be QRS, but SA node to the AV node. And then through the bundle of his, your Purkinje fibers around your ventricles, and then your ventricles are going to contract, and then that is, in our electrocardiogram, that's our QRS, right? And then the T is when the ventricles are relaxing, and the atria simultaneously are also relaxing. Okay? And then you would want to be able to recognize that when you see it. You would want to be able to differentiate between the pulmonary and the systemic circuit, and whether or not the blood is oxygenated or deoxygenated. Do you need me to go over this at all, or you feel pretty confident? Pretty simple stuff? Okay. And then next, we talked about the importance of the hepatic portal vein, and I reviewed that in class today as well, so you're probably pretty good on that one. We talked about blood pressure, systolic over diastolic. Systolic is when you have the greatest force, diastolic is when it's relaxing. And then we already talked about the importance of veins. Yay, that's a favorite. And then we already know what's dissolved. And we learned about these things in our immune system, so I want to jump right to here. Okay? And this is this dynamic balance at the capillaries. Two pressures at waging a war against each other. What are they? Hydrostatic and osmotic. Hydrostatic says out. Osmotic says in. Who creates the hydrostatic pressure? Heart. Who creates the osmotic pressure? Yeah, the gradient, the dissolved substances in the blood. Okay? If more gets pushed out than drawn back in, you have some leftovers out there in your tissues. Who's going to pick that up? The lymph. Exactly, it becomes lymph. Your lymphatic system picks up the excess. Your lymphatic system will then pick up that excess tissue fluid and pass it through a lymph node. Who could be waiting in the lymph node? What? Macrophages? B cells? T cells? Say my name, say my name. You know what those are, right? And then it'll return it at the left and right subclavian vein in order to keep your blood pressure the same. So we had these two pressures, right? Here, here, hydrostatic, osmotic. Yes? You feel good with that? You understand it? Okay. Next, the immune system. No, I don't. Okay, so things I would know in your immune system, okay? Do you think it's important to know the evolution of the immune system? Yes. Okay, so we talked about slime molds. Why did I bother talking to you about slime molds? I think that was the unicellular part of the slime mold, or when they're living together that I was more interested in? Living together, why?
Because some of them work as like guards.
Yes, what did we, this started with an S. Sentinels, yeah. That patrolled, right, the multicellular stage of slime molds. And remember, they went into a multicellular stage when conditions weren't as good. Then they move into their multicellular stage, and they had sentinels who would patrol it and look for anything that would trigger something that could harm them. And we talked about, remember, PAMPs and TLRs? TLRs were toll-like receptors, right, that could recognize it, and PAMPs were from the pathogen, right? So pathogen-associated molecular patterns, okay? So these were the different receptors, and then I had, we looked at this picture here, right? So you could see the PAMPs, and here's some PAMPs. These same PAMPs, right, are the things that are going to trigger our own innate immune response, right? So we know you don't belong here. If you don't belong here, what am I going to do to you? I'm going to attack you. I'm going to try to destroy you. We looked at some of the different things that could be PAMPs, right? Anything that could trigger it. It could be a nucleic acid, right? It could be a carbohydrate. It could be a protein. Okay? We talked about how the lymphatic system is integrated with the circulatory system. At every capillary, you have lymph capillaries. They're going to pick up that excess tissue fluid. Yes, that's one role they play. Not only will they pick up that excess tissue fluid, they will monitor it to see if there's any PAMPs in there. Because if we got some PAMPs in there, we're going to need to destroy them. Yes? Okay. So then we talked about how the lymphatic system is extensive. We talked about how their lymph valves to keep the fluid going in one direction. We talked about how we didn't want that. We talked about the primary organs are your bone marrow and your thymus gland. Okay, and all lymphocytes, okay, are originating in your bone marrow, but the special forces guys, the B cells, would mature in the bone marrow, whereas the T cells mature in the thymus. Okay, and so bone marrow and thymus gland were your primary. Your secondary organs are things like lymph nodes and your spleen. Lymph nodes are monitoring what? Tissue fluid. whereas the spleen is monitoring your blood. Yes?
What are macrophages?
Macrophages are still going to originate from your bone marrow, but they would be in the white blood cell non-specific origin. And that would be, here I'm coming up on that right, let me find you a picture. Here, okay? So, but I don't know if they're in this picture. Are they? Oh, yes, they are. Okay? So in your bone marrow, you have your cells that your B and T lymphocytes and your natural killer cells are going to come from, right? But then you have, here it is in this picture, natural killer cells. Remember the natural killer cells were going to be like T cells, but they didn't go where? To the thymus. Okay? Then the rest of these, your red blood cells, your platelets, and all your white blood cells come from your myeloid stem cells, also from your bone marrow. And monocytes are precursors to macrophages. They're smaller, but that enables them to get out and get into the tissue fluid, and then they grow up and become larger macrophages and more long-lasting than neutrophils, which are primarily it's like 70% or so of your white blood cells are neutrophils. They're first on the scene. They'll set off alarms. Macrophages, they're a little bit slower, but are more long-lasting. I saw a hand up.
Yeah, so I know T cells only kill your own body cells, like once they're
Okay,
infected.
so let me get to that. I'm gonna head there in just uno momento. I want make sure you review barriers, right? And then make sure you remember what antigens are. Make sure you understand the inflammatory response, okay? And the role of each of them in that process. Make sure you understand complement proteins and what they do, and about drilling holes. Remember, that was your favorite video. And natural killer cells, okay? And then when when you look at this picture now, you should feel pretty comfortable with all of these guys over here in your innate immune response. No memory. They respond with the same amount of response every single time. Over here, your special forces, B and Ts, okay? All right, so remember, we have two issues. When we have a pathogen get in our body, we can have free-floating pathogens that are just in our plasma and in our tissue fluid. Then we could have those pathogens that actually get in our body cells. So B cells, by being the ones that generate antibodies, they don't kill anything. B cells kill nothing, but they're still part of special forces, and still we must have them to overcome the disease. Why? They make antibodies that target that particular antigen and mark it for destruction. Okay, they go along and tag everything that needs to be destroyed. So then when other cells come through, they're like, kill that, kill that, kill that, save that, kill that, kill that, kill that. Makes it be effective. It's because you brought donuts. And then T cells, they take care of our own cells that have gone bad, like if they're cancer cells, then they'll wipe them out. And they will also wipe out our own cells that have been infected, our own body cells. So now, Ori, ask your question. Okay. All right. So you need a combination of both to take out whatever that pathogen is, because our general forces just can't usually take care of it. So we start off always with virgins, right, that have never come in contact with that pathogen before. And that's why on your first initial response takes 10 days to 2 weeks. That, if you remember these lovely slides, when you first come in contact, some antigen presenting cell is going to engulf that pathogen, present it, and that antigen presenting cell, is he going to present on an MHC1 or an MHC2? MHC2, and I will help you. Okay? All right. So you present on an MHC2, and only a few cells have those MHC2s. B cells and antigen presenting cells like macrophages and dendritic cells have MHC2s. Yes?
Okay, so things like bacteria, T cells kill those?
No. Why?
T cells only kill your own cells?
They can only kill eukaryotic cells.
So what kills bacteria?
So macrophages can eat them, and they're marked with antibodies so they get destroyed.
Are those B cells?
B cells make antibodies. Macrophages and dendritic cells are part of your innate immune response.
So not viewing T cells at all.
No.
So like, what are they classified as?
What is who classified as?
The macrophages.
White blood cells.
Okay.
Yes. Okay, go ahead.
So in between like the B cell and then it presents the like antigen and then the T cell, you said there's MHC2, right? But who presents that? The B cell or the T?
Generally speaking, a B cell, you've got to get the first ones you have to trigger of the two of your special forces are your T cells initially in your virginal response. Okay, it's got to be the T cells, and because that T cell is going to get presented with an antigen, that T cell receptor is going to detect that antigen. He's now activated. He will grow and divide, and he will make 3 types of cells. What are the 3 types of cells he will make? Memory cells for next time, cytotoxic T cells for killing, and helper T cells. And it's that helper T cell who's going to come along to a virgin B cell who's come in contact with that antigen for the first time, and it will come in direct contact with the virus or the bacteria. The B cell receptors come in direct contact with the pathogen. Whereas a T cell, the only way you can talk to a T cell is if it's presented on an MHC1 or an MHC2. If it's not presented on an MHC1 or an MHC2, it's not going to recognize it. And then that will stimulate the B cell, and then the B cell will produce 2 cells. What are the 2 cells he'll produce? Plasma cells, which will generate antibodies, and also memory cells. And you will make clones, a clone army, clonal selection of that particular B cell and that particular T cell that recognize that particular antigen. They will fight the war, they will win the war, hopefully, and then they will all commit apoptosis, except for the memory cells. Okay, putting it all together? Yes?
So, like, say there's like a macrophage eats an antigen, right, and then like that then the MHC2, give that directly to the B cell, because it helps T cell.
B cell doesn't listen like that to MHC1, MHC2. B cell will listen to a helper T cell talking to it. It'll listen to cytokines that are released. It'll listen to interleukins, chemicals secreted to pump up the immune system. But it responds directly to the pathogen.
So, like, can a B cell come in contact with an antigen and respond to it or no? Right?
Yes, absolutely. That's what it's doing right here. Okay? So, to stimulate your T cell, notice he has to present this on his MHC1, or in this case, an MHC2, right? Okay? And it'll stimulate this helper T cell. Now, this B cell is coming in contact. Notice this particular B cell only recognizes this pathogen, not this guy up here, not this guy up here, just this one. That's the only one he can recognize. Okay, so he came in contact with that pathogen. This helper T cell who recognizes that same one says, yes, you're right. So now he grows and he divides and he forms 2 types of cells, plasma and memory. And the plasma cell is what's going to secrete all the antibodies that mark that same pathogen for destruction.
So you
Yes.
universally have either like the humoral response or the cell mediated response. You have to have a helper T cell.
Yes,
Okay.
first.
Right.
Now, non-virginal memory cell ones, you don't need each other in that whole, it's a good checks and balances, right? Because think about it. People who don't have that working well for them attack their own tissues. Those are called autoimmune diseases, right? You attack your joints, you attack your tissues, you attack your nerve endings. You attack your islets of Langerhans, right? And diabetes, and so type 1. And so you want to be sure before you turn on a war that you're attacking the right thing. But once you have attacked it previously, they assume it's still bad. So if you come in contact with it again, it responds right away. That's where that graph I gave you where the antibodies jump up really fast, really quickly. Doesn't take any time at all. Because it doesn't require all those checks and balances. Okay, more on that. Okay. Is it clear in your head now?
Yeah.
Is it getting there? Okay. And we talked about those antibodies are called immunoglobulins, and you didn't have to memorize all of these, but they do have different functions, but I definitely did want you to know mast cells. Okay, on cell-mediated, remember, you have, oh, sorry, with my upgrade, this got lost. So, we'll just leave him right here. And these right here, okay? So, cell-mediated, you have helper T cells and you have cytotoxic or killer T cells. Notice it's our cancer cells or virus infected or a bacterium infected eukaryotic cell. That's what they can attack. All right, are you good on your MHC1s, MHC2s? Do you need me to go over that at all? No? Wouldn't hurt? Okay, so if you display on, what do you have more of, MHC1s or MHC2s? MHC1s. Come on in. I'm just doing a review. Did you see all that I posted about monster quiz?
No?
Oh, I got
Just now?
No, this whole class on Instagram.
Oh.
All of them doing monster.
Really? What is this, a study period?
Yeah, I'm doing a 7th period support. Yeah. So, but there are videos up.
On Twitter?
On Instagram, but it should have gone over to Twitter as well.
Okay,
Not
I'll
my
check.
Winnie Litton-Clitter.
Oh my
Twitter.
god.
But I'm so glad this is getting recorded. Not my Winnie Litton Twitter, but Miss Litton Biology Twitter. It's on that one. Yeah. Awesome sauce. Okay, come back to me. Another day in this classroom. All right. MHC1, MHC2. Most of your body cells have MHC1s. Almost all of your body cells. The only ones that have MHC2s, B cells, dendritic cells, okay, macrophages. Everybody else, even T cells have MHC1s. So if they are showing, if they're displaying that virus or pathogen on your MHC1, you are done. I remember I said it's stabilized with the CD8. I will 8 you. That protein is stabilizing that interaction, and that you're going to kill. That's a sign of an infected cell. If you display on an MHC2 because you happen to have MHC2s, and you display on that because that's what you have, you're saying, I have overcome this. I'm a soldier. I fought it, and I am presenting it to you, and I am letting you know that I'm going to kill it. Can you help me with that killing? And the last chapter, chapter 34, was digestion. We reviewed that in class today, and it's also posted on YouTube. Do you have any other questions you want to ask me? Yes?
What exactly is a dendritic cell?
A dendritic cell is, it picks up like the waste products of what the battle is going on, and it is an antigen presenting cell, and kind of cleans up the scenes. Yes? Oh, anything else?
I have a question.
Yes.
So remember last time how you made the HSRT and essay? Are we gonna do that again?
Oh, good question. You know what? I already wrote the test, and I think I forgot to do that.
In general, like
Well,
the HSRT.
you're a busy person, no need to change.
You have to go, you fly out today.
Yeah. I think we already went
I totally forgot to put a highly suggested reading and thinking. You want? I can put one in. Okay, yeah, I didn't put any in. I know I didn't.
That's totally okay.
Wait, let me just double check.
You wanna we can check for you if you want. I'm okay with that.
No, if you have an HSRT, you know that's that's one more question if you don't know.
Oh my gosh, I totally forgot to do that.
It's okay.
No, I didn't ask about it. No, I just
You don't need to waste your time now.
I know.
What? Oh, guys, respiratory system. 35's in there too. Yes. Sorry, I totally left that one off. 35. 35. Don't forget chapter 35. No highly suggested reading and thinking.